Okay, this one is lesson 1-5 and 1-7. Sorry. Lesson 1-5 is going to be graphing two variable inequalities. 1-7 is going to be graphing systems of two variable inequalities. Okay, so basically last slide what we were going over was hey, you got x less than 2. How do we graph those? Well, now we're going to be looking at things like y less than or equal to 2x plus 1. Okay, so the first thing that I want you guys to do is we're just going to talk about what are inequalities with two variables. So an inequality with two variables are called linear inequalities. These are called linear inequalities. Why do you guys think that we would call it a linear inequality? Well, they resemble our linear equation. The only difference is that there's an inequality sign where the equal sign usually is. Okay? So I've got y equals 2x plus 1. Okay? And that was graphing lines. And we've done that for a little bit now. Okay? But now if I get a y less than or equal to 2x plus 1, I've got that here. Okay? So what's the difference is if I have a linear inequality versus if I have a linear equation versus a linear inequality. So the only difference between these two lines is the fact that this has a shaded part. Okay? So I believe that should look somewhat familiar to you. Basically is if I've got a y and I've got a less than, greater than, less than or equal to, greater than or equal to any of those, you're going to graph the line just like normal, but you're going to shade one of the sides of the line. And the reason is there's a whole lot of solutions to that problem, and it's all this shaded area there. We'll talk about that a little bit more later. Okay? Now, next thing that we need to spot the difference between. Okay? I've got a y less than 2x plus 1, and that looks like this graph right here. Then I also have a y less than or equal to 2x plus 1, and that looks like this graph here. Okay? So equation-wise, this is a less than sign, and this is a less than or equal to. So what's the difference between those two sides? Well, for this one, we have just a less than. We're not including it. For this one, we have a less than or equal to. We are including it. Last time, this meant closed circle, and this meant an open circle. But I cannot draw an open line. That is not possible to draw an open line. So we aren't going to be able to use an open circle now when I'm trying to draw these lines here. So what we do is if you have a less than or a greater than sign, when you graph your line, you need to use a dashed line. Okay? Versus if I have a less than or equal to or a greater than or equal to, we will use a solid line. Okay? So again, just to reiterate, okay, last time if you guys had a less than or a greater than, that meant that you had an open circle. Now for this one, if I have a less than or a greater than, that means that I'm going to draw a dashed line. So that dashed line, the fact that it's dashed, is what is showing that we are not including numbers on that line. Versus if I have a less than or equal to, greater than or equal to, we use that closed circle. We wanted to show that those values were included. So now if you have a less than or equal to or greater than or equal to, you will use a solid line to show that points on that line are included. Okay? One more thing that we want to talk about is we are going to say what are the solutions for the inequalities with two variables. Okay? So I have a picture up here of a graph, 2x plus 4y less than 6. Okay, and I mentioned this on the first slide there, that this shaded area told us where our solutions were, and that's why we shade down there. Okay, so your solutions are going to be any points that make the equation true. Okay, so an easy point to look at. Let's say I wanted to look at 2, 0, plus 4, 0, less than 6. So I'm looking at the point my x is a 0 and my y is a 0. So the point 0, 0. Okay, well 0, 0 would be right here on the graph, right? So it's going to be a solution if it makes this statement true. So 2 times 0 is 0, plus 4 times 0 is 0, and I get 0 less than 6. And that's true. So that is true. So since it's true, that is a solution. So again, it was in the shaded area. I knew that it was a solution. I knew it was going to be true. Okay? So let's pick another point in the shaded area. Let's say we're going to pick the point -3, +2. So now we're going to pick the point -3, +2. Okay, so I'm going to plug that into this equation. 2 times -3 plus 4 times 2, that's a +2, is less than 6. -6 plus 8 is less than 6. So that gives me 2 less than 6. And again, that is true. Okay, any point that you pick in the shaded region will be true. What if I pick a point on the outside? Let's say I picked a point out here. That point is 6, 0. Okay, 6, 0 should not be a solution because it's not in the shaded area. So let's check that out. 2 times 6 plus 4 times 0 less than 6. That's going to give me 12 plus 0 less than 6, 12 less than 6. Is that true? No, that is false. Okay? Now on this next slide, I'm going to show you guys how to graph these and how to determine where to shade. But once you determine where you're shading at, that tells you where all of your answers are. All of your answers are going to be any point that is in that shaded area. Okay? Now, that should lead you to the next question, which the next question is, what about these points on this line? What if I look at this point right here, 3, 0? Is that true or is that false? Okay. Well, remember what we talked about a couple slides, or no, last slide. It was last slide. Okay. What does that dashed line tell us? Does that dashed line mean that we are including those points, or does that mean we're not including those points? Well, remember, the fact that it was just a less than told us that we were not going to include those points. So 3, 0 is not a solution either. Okay? And you guys would figure out that would be true. I'm going to show you over here. 2 times 3 plus 4 times 0 is less than 6. The 0 is gone. 2 times 3 is 6. So 6 less than 6. Is that true? No, 6 is not less than 6. That's not true. Okay? If this would have been a solid line, though, if that was a solid line, would 3, 0 work? Yes, because if it was a solid line, we would be including 6, so that would work. Okay? So hopefully that kind of explains how you guys find your solutions based on these things. And now we're going to talk about this next part with how to actually graph these things. Okay, so you need to graph 2x plus 3y less than 6. Okay? Your first step when you do this, step 1, you need to get it into y equals. Okay? The first step I need to do is get this into a y equals form. Why do I want it in y equals form? Well, because we need to graph this line. Okay? So I'm going to start out 2x plus 3y equals 6. So notice I said I got to get it into y equals form, right? So I'm just going to go ahead and write that as an equal sign. And I'm going to solve this like I know how to. I'm going to subtract 2x to both sides. And when I do that, I get 3y equals -2x plus 6. I'm going to divide everything by 3. Divide everything by 3. And I get y equals -2/3 x plus 2. Okay? So step 1 is to get into the y equals form. Step 2 is going to be to graph it. Okay? So step 2 is going to be to graph it. So I've got a y-intercept at 2. And I've got a slope of -2/3. So I can go down 2 to the right 3, down 2 to the right 3. I could also go up 2 to the left 3, up 2 to the left 3. Either one of those would work. Okay? So I'm ready to graph that thing. But I need to determine when I graph it, is it a solid or is it a dashed line? What kind is it? Solid line or a dashed line? So I'm going to look up here. Is this going to give me a dashed or a solid line? Am I including it, meaning I need a solid line, or am I not including it, meaning I need a dashed line? That should give us a dashed line. Okay? So when I draw my line between these, I'm going to make sure that I make that dashed. Okay? Step 4, I need to decide which side I'm going to shade on. So for step 4, determining which side to shade, I'm going to use a test point. And the best test point is 0, 0. The best test point to use is 0, 0. Now, when I use the test point 0, 0, I can always use that unless my line runs through 0, 0. If your line runs through 0, 0, you're going to have to pick a different one. Okay? But I'm going to use 0, 0 for my test point. And when I do that, I'm going to plug that back into my original equation up here. So 2 times 0 plus 3 times 0 less than 6. That gives me 0 less than 6. Is 0 less than 6? Yes, it is. 0 is less than 6. So since 0 is less than 6, okay, we're going to use a test point. We're asking ourselves where to shade. So I'm going to write step 5 is going to be if true, shade with the test point. And if false, shade away from your test point. Okay? So my test point was here at 0, 0, right? Test point was at 0, 0. I got a true statement. So when I shade this, I need to shade on the same side as my test point. And I'm going to shade this entire area down here to make sure that you guys know any point that is in this shaded area, any point in the shaded area would be a solution to this linear inequality. Okay? All right. I'm going to have you guys pause the video, try this one on your own. Okay, hopefully you have this paused. So we're going to go through again. First step, we just need to get this into y equals. So I've got x minus 4y equals 8. Subtract x, subtract x. I get negative 4y equals negative x plus 8. Divide by a negative 4, divide by a negative 4. Everything's divided by a negative 4. I get y equals a positive 1/4 x minus 2. Okay, so I've got minus 2 here, and I'm going up 1 to the right 4. I could also go down 1 to the left 4. Okay, so there's my points. Do I need a solid or a dashed line? Well, that's telling us we need to include those, so that needs to be a solid line. Okay, so we've got a solid line running through those. Then I need to determine, should I shade above or should I say shade below? Shade above or shade below? Well, let's use our test point. And I'm going to use my favorite test point because I can. Okay, 0, 0. As long as it's not running through 0, 0, we can use that. Test point 0, 0. So that's going to give me x minus 4y less than or equal to 8. So I've got 0, 0 there. Okay. That's just 0. That's just 0. So I get 0 is less than or equal to 8. 0 less than or equal to 8. So that is true. That is also a true statement. Remember, when you get a true statement, you shade with the test point. So the test point is on this side. So I'm shading with my test point on the top side of it. If I got a false statement, then I would be shading away from the test point. I would have shaded down below the line. Okay? So that's how you guys are going to graph your linear inequalities. Next video, we're going to do multiple linear inequalities. So basically, it's the exact same thing, but you're going to be graphing two of these lines on the same graph.